Okay, welcome back to Chapter 1, Section 5, Uncertainty, Accuracy, and Precision. Let's talk about scientific notation. So, this is another way to approach the magnitude problem, expressing the size of a number separately from the measurement, right? The international system uses prefixes. That collapses the numbers, gets rid of all the zeros that tell us about the size. And that's good because it's easy for people to work with. Okay? People are really good at jumping between those units. With a little bit of practice, people are good at jumping between those prefixes. But it's not great because you have to memorize a couple dozen prefixes, right? Well, a dozen to start. But then as we go further and further out from, just the basic unit, you have to have more and more prefixes. You have to invent more prefixes, memorize more prefixes, and so on. And finally, computers and calculators hate this prefix system. It's a real pain in the keister to program computers with all of these prefixes and teach them how to convert between them, and it's just awful. Which is why we've come up with scientific notation, or exponential notation. Two different names for the same thing. This is another way of dealing with magnitude. You just completely take the magnitude out, make it a completely separate thing. And it's great because computers love it, and it's also great because it's perfectly flexible. Okay, it works at any magnitude, you don't have to invent anything. But it's not as pretty or romantic. It's not quite as intuitive. You have to put a little bit more effort into really grasping these different magnitudes, but it's just so flexible that we absolutely almost always work with it now. The prefix system, it's not going to go away, but the scientific or exponential notation, it really is here to stay. So let's look at the notation itself. The speed of light is about 299,790,000 meters per second. A hydrogen nucleus, as I've said before, is about 1,756.6 quintillionths of a meter across, or 299.79 megameters per second, or 1.7566 femtometers. How's your memorization there, right? But in scientific notation, really straightforward. 2.9979 times 10 to the 8th meters per second, and 1.7566 times 10 to the negative 15th meters. Okay. You can see we still have all the actual information at the measurement, the 29979 and the 17566, all right there. And the actual size of the number has been turned into an exponent, okay, hence exponential notation. So the fact that, the speed of light is a big number, well, that's right there in the fact that we have that positive 8 as the exponent on the 10. Whereas the 1.7566 is a really, really tiny number, a tiny little decimal. That's the fact that we have the negative exponent on the 10. Okay. So the way it works is we're multiplying by 10 to some power. Okay. So you multiply by 10 to the first power, the number gets 10 times bigger. Right? 3 times 10 to the first, 3 times 10 is 30. Okay. 3.2 times 10 is 32. Okay. But if you have that negative exponent, that means you're dividing by 10, is really what that means. 10 raised to some power. Okay. So 10 to the negative 2, okay, that's divided by 10 squared. Divided by 10 to the second. So 10 to the second is 100, so it becomes 100 times smaller. 3.2 times 10 to the negative 2, that's 3.2 divided by 100, that's 0.032. Okay, so that's what this exponential notation gives us. Okay, it gives us, in one really condensed form, all of the information of the measurement, 29979, and the size of the measurement, times 10 to the 8th, and the units. It gives us all 3 parts of the measurement in 3 separate chunks. So really, really great for that. And then the number on the exponent, that just tells us how many places we've moved the decimal, is really all we're doing. Okay? So you go back up to the speed of light up the top, 299790000. Okay, there's that invisible decimal place, right? At the very end of the number. We just moved it 8 spots to the left. 0000799. 8 spots. Okay. That's how we got that number between 1 and 10. Likewise, that 0.000000000017566. Okay, we've moved the decimal place over. Every time we move the decimal, that's another number on the exponent, and that's how we got that number 1.7566 times 10 to the negative 15th. We've moved the decimal place 15 steps to the right. So there it is. Number, magnitude, unit. All 3 portions. And now, instead of, some weird number, it could be ones, tens, hundreds, thousands, whatever, we have a number between 1 and 10. That is, people really like that. That is a really convenient thing to always have, is a number between 1 and 10. And that's your measurement. And then you have your magnitude that tells you the size. Is it a big number? Is it a small number? Is it a really big number or a really small number? Really easy to do, just a different size exponent. And then you have the units. And we don't have to memorize different prefixes for this, because you could work with any units you wanted. You could have 4.370 times 10 to the third meters, or you could have 3.47 times 10 to the negative sixth kilometers, or whatever. Okay, scientific notation is perfectly flexible in that way. So, like I said, converting some number into scientific notation or exponential notation, you just move the decimal. However many spots you move the decimal, that's the number. And what direction you move the decimal, that's the sign. Moving to the left is a positive exponent. Moving to the right means a negative exponent. Every step to the left, the exponent goes up 1. Every step to the right, the exponent goes down 1. So that number up at the top, 138, followed by 9 zeros, that's 1.38 times 10 to the 11th. So, here's a couple more examples. 0.000863. You move the decimal place to the right until you have a number between 1 and 10. And that gives you 8.63 times 10 to the negative 4th, because the decimal moves right 4 spaces. 0008. And then you have 103000. You have your decimal place, you move it to the left 5 spaces, that gives you 1.03 times 10 to the 5th. And the thing is, we prefer to have our numbers between 1 and 10, but it doesn't have to be. Okay, scientific notation is flexible in that way. 1.03 times 10 to the 5th, that's the exact same thing as 10.3 times 10 to the 4th, or 103 times 10 to the 3rd. We just moved the decimal place, to a different spot, and that gave us a different exponent. That's perfectly fine. Exponential notation is really flexible in that way. So we can compare things at different scales, or we can compare things at the same scale, okay? We can just shift things around so that they have the same magnitude, and then we can look at the numbers and see, oh, it's a lot bigger in that way, or a lot smaller, or about the same. You still need to pay very careful attention to your units with this, okay? Because, like I said, perfectly flexible, you can mix and match your prefixes all you want to, and people frequently do. So pay attention to your units. Make sure it's apples to apples, oranges to oranges, right? Because 1.03 times 10 to the 4th grams is still going to be 1,000 times smaller than 1.03 times 10 to the 4th kilograms. So, be careful. Pay attention to your units. You'll be okay. There are different ways of writing out exponential notation that still amount to the exact same thing. It depends on the computer program or calculator you're working with. Okay. Sometimes the calculator is nice and pretty, and it will actually write out times 10 to the something. But other times, they don't. This harkens back to when computers, they could do the math, but the graphics were a little bit less flexible. So, the letter E got drafted into this. Okay, E for exponential, right? So 3.75 times 10 to the 5th might be written as, depending on the program or calculator, 3.75 E plus 0.5, or 3.75 E5, or 3.75 E05. Capital E, lowercase e, sometimes they'll have a plus or a minus. It's all different ways of saying the same thing. And that's just really a limitation of the computer program. Okay? But either way, it still gives you this really nice condensed notation that gives you both the number and the magnitude. Here's another thing to be careful of. The e for exponential is not the e in e to the x. Okay, that is the natural logarithm sort of thing that deals with a very, very different sort of thing, a whole other mathematical thing. So be very, very careful about that, especially when you're putting stuff into your calculator. If you mean to use one e when you should be using the other e, your numbers can come out completely wonky and wrong. So, different calculators handle exponential notation differently, and so do spreadsheet programs and the like. Be very careful about that, and I am more than happy to help you out with your calculator. In person, don't send me pictures of your calculator or anything. I'm not going to, no. If you don't know how the calculator does it, I'll take a look at it and help you out with that. And one final note. Your calculator is stupid. It will do exactly what you tell it to do, not what you want it to do. So if you type out directly 3.8 times 10 to the third divided by 1.9 times 10 to the negative second, depending on how you put that into your calculator, the answer will either be 2.0 times 10 to the fifth or 2.0 times 10 to the first. Okay? 20,000 or 20. That is a huge difference. Now, the answer you want is 20,000. But if you just type in 3.8 times 10 to the third divided by 1.9 times 10 to the negative second, all directly into a fairly simple calculator, the answer you're going to get is 20. And that's wrong. Okay? The reason is, what your calculator will do is it will multiply 3.8 by 10 to the third. Then it will divide that by 1.9. Then it will multiply that by 10 to the negative second. What you wanted was 3.8 multiplied by 10 to the third, and 1.9 multiplied by 10 to the negative second. Then the first number divided by the second. So, either get good with using parentheses, or get good at using the exponential notation on your calculator. Because if you put it in correctly with the exponential notation function that your calculator provides, it will never make that mistake. It will always correctly pair the number and the magnitude that you want to stick together. But if you just enter times 10 to the third, it won't know to do that. That's what you need to be careful with. That's what you need to watch out for. So once again, to reiterate, I will show you how your calculator handles exponential notation if you don't already know, and assuming I can figure it out. And once I do, you have to use that, or your answers can end up really weird. And that'll do it for Section 5. See you next time.